This video is going to show you how to find the lag time, but then also use that lag time to find the distance to the epicenter. We're going to look at two different ways of doing this. The first one, we're going to look at a seismogram that's given to us, and we need to first find the lag time. So it's important to remember that to find the lag time, we have to only look at the P and the S waves and when they arrive. One thing that I do just to kind of help is I just go straight down from the P wave and mark that on the number line, and then do the same for the S wave. And I go straight down and mark where that would fall in the timeline. If we look at this, these are simply just increasing by 1 minute each time. So if this line over here represents 15, this one 16, 17, 18. So the P wave came through with 18 minutes. And then if we look here, the S wave came through at 20 minutes and 30 seconds. I'm just going to represent it 20:30. The lag time is the difference between those two. So you would subtract them, or you could just use it like a number line and count as is. And when I do that, I just look and see that I have 1 minute, 2 minutes, and a half. So the lag time is 2 minutes and 30 seconds. Now we have to use that 2 minutes and 30 seconds in order to find the distance to the epicenter. So what I'm simply going to do is I'm going to get my graph and my colored piece of paper, and the first thing that I need to do is make sure that the paper is in the corner. Okay, and one thing that I'm actually going to do to kind of help is I am going to draw, and something that you should do as well, just a little arrow pointing to that bottom corner so that you remember that that corner always has to stay on the P wave. So I'll actually even say, I'll put on here P. I'm going to group this. Okay, so whenever I move this paper, there's two rules that you have to remember. The first rule is the bottom corner is always going to stay on the P wave. So if you notice, even if I move it up here, the corner has to stay on the P wave line. If I move it down here, the corner has to stay on the P wave line. The second rule is you cannot rotate the paper at all. It should always be vertical, straight up and down. So please do not rotate it either direction. Step one that we need to do is we need to look back and remember that our lag time was 2 minutes and 30 seconds. So I'm going to start by putting the paper in the corner, and I'm going to leave some space so that I can see all of these lines. Then I'm going to mark where 2 minutes and 30 seconds would be. So if I look at this paper, this is 2 minutes and this is 3 minutes. It's important to understand what these lines are increasing by, and it's also important to remember that there's 60 seconds in a minute. So when we're looking at these lines over here, this first line is actually going to represent 15, and this line up here is going to represent 45. And that's something you might want to write in on yours as well so that you remember, because it's important, because even if you screw up just a little bit over here, it's going to make a difference in your answer. So I've put the paper in the corner. I need to find where 2 minutes and 30 seconds would be. Well, it would be right in the middle here. So all I'm going to do is be as accurate as possible, and I'm going to draw a line. And then next to it, I'm just going to write 2:30, because eventually you're going to have a lot of lines on here. So you want to make sure that you can kind of keep them all straight. So I'm going to mark mine with 2 minutes and 30 seconds. Now, I need to remember the two rules that I said. So we can't rotate it, and the bottom corner always needs to stay on the line. What you're simply going to do is just keep sliding, and you're going to know when you're in the correct spot when the corner is touching the P line and the little line you made comes in contact with the S wave. So you can see right now, and I can even highlight it for you, there is still a gap here. So if you can see, we're still not coming in contact with that line. So that's not going to work. So I'm just going to keep sliding, and you can see here I'm getting a little bit closer. I would say here I'm pretty close. So I'm going to check to see if this one's a little bit better. And I would say either one of these would be acceptable. On your paper you might get more of an accurate one. And if I measure this up more, I actually think that's a little off. So I'm going to go down one, and I'm going to say that this is the most accurate one. So if you look, let's go This corner right here comes in contact with the P line. This little dot that you made for 2 minutes and 30 seconds comes in contact with your S line. Paper is straight, we're vertical, so that's going to be really important. What you are simply going to do is just go straight down, and we need to see what that measurement's going to be. So another thing that you might want to write on your paper is each of these lines are increasing by 200. So I'm just going to put increasing by 200. So if this line right here is 1,000, then we have 1,200, 1,400. So what that simply means is the distance to the epicenter is 1,400 kilometers. So even though Boulder, Colorado is what felt the earthquake, the epicenter of the earthquake is still 1,400 kilometers away. So we had to find the lag time in order to use that distance, and that's how we solved that. We're going to do one more just for practice, and then also just another way of looking at it. So if we start here, this is just a different way given to you. So this is actually giving to you in numbers. And it's important to realize that that's hours, minutes, and seconds. Okay, and we have to do the difference between the S wave and the P wave. So S wave comes in at 1:17:40. P wave comes through at 1:13:10. We're going to subtract the two, so 40 minus 10. So you're just going to do this in sections. And actually highlight this. So we're only subtracting this little area, and then we're only going to look at this area, and then we're only going to look at this area. So you don't really combine them. So we have 40 minus 10 is 30. You have 17 minus 13 is 4. And then 1 minus 1 is 0. So this is a lag time of 4 minutes and 30 seconds. So just like we did earlier, we're going to use our chart. We are going to start by putting this in the corner, leaving some space so that we can see it. Remember that the lines are going up by 15 seconds, so that's really important. And we are going to mark where 4 minutes and 30 seconds would be. So right in the middle of those two, I'm going to draw my line as accurate as possible, and then I'm going to label it so that I don't get it mixed up with any other ones I might have on my paper. I'm going to remember this arrow needs to stay on the P line. And then we are going to slide. So remember, no matter where I go, this bottom corner needs to stay on the P line, and at no point can I rotate the paper. I'm going to stop when this top comes in contact. So for example, if I go here, you can see that we're not quite there. If I go up to here, we're running out of room. Even if I stop here, there's still a big gap. So I'm going to keep sliding until I see the most accurate one. And again, it's important to be as close as possible. So when you think you found it, which I think I did right here, it's always a good idea to go one before and one after just to see if there's a better one. And I think it's this one. So I'm going to stop here. I go straight down, grab my highlighter. You don't have to do this part on your paper, but I think it helps to see. I'm just going to go straight down this whole edge. This a little thinner. If you go straight down this whole edge right here, you then look to see what the distance is. We're looking at this number right here, and this one's nice and easy. It falls right on the 3, which remember, it's in thousands. So when we go back to our paper, our distance from the epicenter is going to be 3,000 kilometers. And that's how it's done.